Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. I request you to subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the TG set exam held in 2024. This problem is from the section complex analysis and it is placed at serial number 107 in the above question paper. And this question is related to the evaluation of the given contour integral. Further, this question is suitable for all these examinations. Right. The given question is the value of the integral taken along mod z is equal to 1 by 2 of the function 1 plus z plus 3z square multiplied by it in brackets e to the power of 2 by z plus e to the power of 1 by z minus 1 plus e to the power of 1 by z minus 2 plus e to the power of 1 by z minus 3 with respect to z is, we are given four options. Right. Let us see what is this mod z is equal to 1 by 2. It is a circle with the center 0 and a radius 1 by 2. Let's see. The x-axis, y-axis. Right. And we have the circle mod z is equal to 1 by 2. It's a circle with the center at 0 and a radius 1 by 2. You also note down the points z is equal to 1, z is equal to 2, z is equal to 3. All these 3 points lie outside this circle. Right. With these observations, let us discuss the solution of the problem in detail. First, note that 1 plus z plus 3z square in brackets multiplied by e to the power of 2 by z is analytic. Is analytic everywhere except at z is equal to 0 because of the presence of e to the power of 2z. Therefore, it is analytic inside and on this circle mod z is equal to 1 by 2 except at z is equal to 0 which lies inside the circle. Right. Now further 1 plus z plus 3z square multiplied by e to the power of 1 by z minus 1 and 1 plus z plus 3z square multiplied by e to the power of 1 by z minus 2 and 1 plus z plus 3z square multiplied by 1 by z minus 3 are analytic inside and on this circle. Why? Its singularities for this 1, for this 2, for this 3, they lie outside the circle. So, these 3 functions are analytic inside and on mod z is equal to 1 by 2 because the singularities z is equal to 1, 2, 3, they lie outside mod z is equal to 1 by 2. So let us call the given integral as I is equal to integral taken round mod z is equal to 1 by 2 into the given function. Now this is written as the sum of 4 integrals. So integral taken round mod z is equal to 1 by 2, 1 plus z plus 3z square into e to the power of 2 by z into dz plus I1 for this, I2 plus I3, where I1 is integral taken round mod z is equal to 1 by 2 into 1 plus z plus 3z square in brackets multiplied by e to the power of 1 by z minus 1 with respect to z. This will be 0. Why? Because this function is analytic inside and on by Cauchy's fundamental theorem, it will be 0. So also here, z is equal to 2. Z equal to 2 lies outside, therefore this function is analytic inside and on mod z is equal to 1 by 2, therefore it will be 0 by Cauchy's fundamental theorem, so also I3. Right. So we are using Cauchy-Gursa theorem, in other words, Cauchy fundamental theorem, and the integrals will be 0 because the integrands are analytic inside and on the circle mod z equal to 1 by 2. So therefore, your I will become integral taken round mod z is equal to 1 by 2 of 1 plus z plus 3z square multiplied by e to the power of 2z dz. Right. So let's evaluate this. Right. We have I is equal to integral taken round mod z equal to 1 by 2 of 1 plus z plus 3z square multiplied by e to the power of 2 by z dz. The integrand, look at that. Z is equal to 0 is a singularity, which we have already said, that lies inside the circle mod z is equal to 1 by 2. And what kind of a singularity it is? It is. Let's look at, let's write down this as the integral taken round mod z equal to 1 by 2 of f of z dz, where f of z is this function 1 plus z plus 3z square into the power of 2 by z. So the singularity z is equal to 0. What type of singularity z is equal to 0 for this function f of z? Look at e to the power of 2 by z and write its Lorentz expansion about z is equal to 0. And in this Lorentz expansion, you have the infinitely many terms in this term. So infinitely many negative powers of 1 by z are there. Negative powers of 1 by z are there. This is the principal part is called. This is the principal part. The principal part consists of infinitely many terms of 1 by z. The terms consisting of the powers of 1 by z. So therefore, this is a singularity. What type of singularity? It will be an essential singularity. So note that z is equal to 0 is an essential singularity of e to the power of 2 by z. And when you have an essential singularity, how do you calculate, evaluate this function? Through residues. So this integral mod z equal to 1 by 2 f of z dz is equal to 2 pi I into the residue of the function f z at z is equal to 0, where z is equal to 0 is an essential singularity. This we are using by Cauchy's residue theorem. Now let's calculate the residue of f z at z is equal to 0. And how do you calculate? This is not a pole. Those rules will not apply here because it's an essential singularity. What you do is take the coefficient of 1 by z in 1 plus z plus 3z square into e to the power of 2z. For e to the power of 2z, write the Lorentz expansion. So in this, collect the coefficient of 1 by z. So 1 into 2 by z, the coefficient is 2. Coefficient of 1 by z is 2. Z into 1 by 2 factorial 2 by z whole square, and that will be 2 by z, and the coefficient is 2. So for this, the coefficient of 1 by z, 3z square multiplied by z, 3 into 1 by 3 factorial into 2 cube. So these are the coefficients. Simplify. 2 plus 1 by 2 factorial 2 square is 2. 3 into 1 by 3 factorial is 1 by 2. 1 by 2 into 2 cube is 4. That is 8. So go back. The integral is equal to 2 pi I into residue of f z at z equal to 0. That is 2 pi I into 8. That is 16 pi I. We have evaluated the given integral. The answer appears against option 4. Therefore, the answer to this question is option 4. That is the detailed discussion of the given problem. Right. It is not a difficult problem. It is an easy problem, what I can say. So in this application of two theorems you have used. One is the Cauchy's fundamental theorem, or in other words, Cauchy-Gursa theorem, and the other is the Cauchy residue theorem, and computation of residues of a given function of z when at z is equal to 0, when z is equal to 0 is an essential singularity. So these are the concepts and the results that what you have used in this problem. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Please subscribe my channel. if you have not already subscribed. Yes, I'm sure we are all going to meet you all once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.